Welcome to Late Night Science. I'm glad you found your way here, to this quiet corner of the night where curiosity is allowed to drift and wonder is free to unfold. Before we begin, I'd love to know where you're listening from. Is it a bedroom wrapped in silence, the glow of a phone on your pillow? A darkened living room where the hum of the day has finally faded? Perhaps a journey, a late drive beneath the stars? Wherever you are, settle in. Let your shoulders sink, let your breath soften, and let your mind wander with me. Tonight, we're setting sail into a darkness more vast than any ocean. A darkness stitched with a pattern you cannot see, but which carries the weight of the universe itself. At first, it feels like emptiness. The night sky above you is punctured by scattered points of light. Stars, galaxies, nebulae. To the unaided eye, it seems random, as though someone has spilled silver dust across black velvet. But as you drift deeper, as your gaze expands beyond what the eye alone can hold, a new picture begins to form. The universe is not a scatter of grains. It is not chaos. Hidden behind the veil of darkness is a lattice, delicate and immense, stretching farther than imagination dares to follow. A cosmic web. This web does not glimmer like spider silk in the sunlight. It is invisible, woven of matter that does not shine, matter we cannot touch. And yet, it is there, holding galaxies as though they were pearls strung on an unseen thread. Imagine walking into a vast cathedral at night, so dark you see only flickers of stained glass catching the moonlight. At first, you think they float in mid-air. But then your eyes adjust, and the architecture reveals itself. Arches, columns, stonework, binding it all together. The galaxies are the stained glass. The web is the architecture. You and I, right now, are suspended on one of those filaments, our Milky Way just a bead on the string. The very fact that we exist, here, in this small world orbiting an ordinary star, is only possible because of this invisible design. Without it, the stars would not cluster, the galaxies would not form, and the universe would be a lonely sea of isolated sparks, too spread apart to build worlds, too diffuse to nurture life. The web is the hidden stage on which the play of existence unfolds. Close your eyes for a moment and picture yourself drifting outward. You leave Earth, gentle as an exhale. You pass beyond the planets, the frozen comets, the faint glow of the outer solar system. Beyond our galaxy's arms, you rise higher still, until the Milky Way becomes a shimmering spiral. Higher still, until it is just one jewel among millions. And then something astonishing happens. Those jewels line up. They cluster. They flow along invisible corridors, threads and bridges that stretch across billions of light years. You are no longer drifting through emptiness. You are drifting through structure. A tapestry in the dark. This tapestry is not still. It hums with quiet motion. Gravity pulls, matter flows. Filaments stretch like strands of honey being drawn across the universe. If you could speed up time, you would see galaxies moving like fireflies drawn toward each other, clustering at the intersections where threads knot together. These intersections are the great city centers of the cosmos, clusters of galaxies so vast they make our Milky Way look like a village. And between them lie the deserts of creation. Voids, immense and silent, emptiness wider than imagination. Together, the threads and the voids create contrast, a rhythm of fullness and absence, presence and silence. It is a rhythm that feels almost organic. The filaments resemble the veins of a leaf, rivers winding across a continent, the neural branches inside a human brain. Again and again, nature seems to echo itself. The small reflecting the large mirroring the small. When you look at a simulation of the cosmic web, it could almost be mistaken for a microscopic image of neurons firing, or fungi spreading beneath a forest floor. The same patterns emerge as though creation itself is fond of repeating a certain design, and yet here in the beginning of our journey, we should pause to hold the paradox. The web is both fragile and unbreakable. It is delicate as silk, invisible to every telescope of the past century, and yet it is the very skeleton of the universe. We stand on the knife's edge of knowledge and mystery. Science can map its shape, trace its influence, simulate its growth. But the deeper question will be, why this structure, why this pattern, why any web at all, remains unsolved, perhaps unsolvable. Between what we know and what we do not know, wonder finds its home. So tonight, as you rest, I invite you to let that wonder settle inside you. Imagine the darkness not as emptiness, but as fullness. A fullness of hidden design, threads too vast for the eye, too ancient for the mind to fully hold. Imagine your own body resting here, is already part of that lattice. Atoms forged in stars that traveled along filaments, pulled across gulfs of space until they gathered in the cloud that became our sun, our earth, our home. You are not outside the web peering in. You are inside it. You are one of its knots, one of its temporary shapes, woven for a while into its living fabric. And now, as you drift at this threshold, ask yourself, if the universe carries this invisible structure, stretching across the cosmos like threads of thought, then what might its earliest moments have looked like? Where did the first filaments come from? What stirred in that primeval darkness to spin such an enormous design? That is where we will go next. Back to the beginning, back to when the first threads were drawn. To see the web that holds galaxies together, we must travel backward through oceans of time to a moment when the universe was not yet woven. Imagine peeling away the stars, erasing galaxies one by one until only a glowing haze remains. The night sky dissolves into brightness, an endless fire where time itself has barely taken its first breath. This is the newborn universe, a child of fire and expansion, where everything familiar is still hidden in potential. The Big Bang is not an explosion in space, it is the expansion of space itself. It begins from a state so dense, so hot, that even the laws of physics struggle to describe it. In that searing beginning, matter and light are fused in a storm, particles colliding and vanishing, reappearing and dissolving like sparks in a furnace. To us, it is chaos, too violent to imagine. But within that chaos there are patterns faint as whispers. They are the seeds of everything to come. Listen closely to that silence beneath the roar. The seeds are fluctuations, tiny variations in density. They are quantum tremors, ripples in the fabric of the infant cosmos. One region slightly denser than another, one pocket holding just a breath more matter than its neighbor. At first, these differences are unimaginably small, like one part in 100,000. Yet in the scale of eternity, such tiny imbalances are enough to change everything. These ripples are the first threads. As the universe expands, cooling with every heartbeat, the glow begins to soften. For hundreds of thousands of years, matter and radiation remain tightly bound, like dancers unable to separate. Light cannot travel freely. It scatters, ricochets, trapped in the thick fog of plasma. And yet, inside this opaque haze, gravity begins its work. The slightly denser regions tug more strongly, pulling in more matter, growing denser still. Fluctuations feed on themselves, gathering, compounding, amplifying. Picture a still pond struck by a handful of pebbles. Ripples spread outward, colliding, reinforcing, cancelling, creating a shifting pattern of peaks and troughs. The early universe is such a pond, but the ripples are not on water. They are imprinted on space-time itself. Where a ripple peaks, matter accumulates. Where it dips, voids will eventually emerge. In this way, randomness gives birth to rhythm, and rhythm sketches the first outlines of structure. For 380,000 years, the cosmos remains hidden in this fog. Then at last, a threshold is crossed. The temperature falls low enough for electrons to bind with protons, forming the first neutral atoms. In that moment, light is released, free to stream through space without scattering. The fog lifts. The universe becomes transparent, and the glow of that moment still shines today. the cosmic microwave background, a faint afterglow stretched thin by billions of years of expansion. Astronomers, with instruments tuned to microwaves, have mapped this afterglow in exquisite detail. What they see is not uniform brightness, but a speckled pattern. Mottled regions slightly hotter or cooler, denser or thinner. These patches are the fingerprints of those first fluctuations. The photograph of the infant universe is grainy, imperfect, yet within that imperfection lies the blueprint for all to come. The galaxies, the stars, even our planet, all are born from those tiny ripples of imbalance. Now imagine yourself drifting inside that glowing fog, long before galaxies exist. There are no stars, no planets, no solid ground beneath your feet, only a vast ocean of hydrogen and helium gas spread thin, yet shaped by those invisible variations. The universe is expanding, carrying you outward in every direction. You cannot anchor yourself, for there is no center, and yet you sense the faint tug of gravity, the subtle gathering of matter, the slow knitting of filaments. This is the quiet miracle. From near uniformity, diversity emerges. From simplicity, complexity arises. Had the universe been perfectly smooth, there would be no stars, no galaxies, no web. But had it been too lumpy, everything would have collapsed into black holes almost immediately. It is the balance, the delicate in-between, that allows structure to form. The cosmos walks a narrow path, and we walk upon it still. As billions of years unfold, those denser regions become the filaments of the cosmic web. They are spun from hydrogen gas and dark matter alike, pulled ever more tightly by gravity's hand. Along these filaments, gas condenses, igniting the first stars. Light flickers in the darkness, fragile but persistent. The web glows for the first time, not with the uniform brightness of plasma, but with the points of galaxies tracing its hidden lines. And so, when you look at the universe today, you are not seeing chaos. You are seeing memory. The pattern of galaxies is the fossilized echo of ancient fluctuations. The grand architecture was drafted in the first moments, long before the first light. Randomness became order, chance became structure, and silence became song. What does it mean, then, that everything we know, every star, every living cell, every thought in your mind, owes its existence to these quantum tremors at the dawn of time? Are we, in some sense, ripples ourselves, frozen patterns in a sea that still expands? Let the question linger as you rest tonight. For the first threads have been drawn, but the tapestry has only begun to take shape. The galaxies will soon find their places, aligning like beads on strings, and with them new mysteries will unfold. Imagine lifting your eyes to the night sky and believing, as ancient stargazers once did, that the stars were scattered at random, jewels tossed from the hand of some celestial dreamer. For millennia, the human eye knew only this: a dome of darkness pricked by solitary lights. Each point seemed alone, each spark untethered, a universe without design. Yet even then, perhaps in some quiet intuition, there lingered the suspicion that the darkness held more than it revealed. When telescopes grew powerful enough to pierce deeper into the night, the stars multiplied into countless galaxies, each one a vast island of suns. And again the first impression was of chaos. Billions upon billions of galaxies distributed in all directions, an overwhelming spray of light without pattern. But slowly, as our instruments improved, a truth began to emerge. The galaxies were not strewn like random dust across a table. They were strung. They gathered in clusters, lined up along invisible paths, arranged as though some cosmic hand had threaded them into necklaces of light. Picture walking into a cavern where mineral veins streak through the rock, glowing faintly in the lantern's shine. The stone looks solid until you notice those branching lines, guiding your eyes deeper into the pattern. Galaxies behave the same. They are the glowing veins of the universe, tracing out hidden arteries across the body of space itself. When astronomers began mapping them, carefully recording the positions of thousands, then millions, the picture sharpened. On paper, it no longer looked like random dots. It looked like threads. In the mid-20th century, early surveys gave glimpses of this order. Clusters of galaxies appeared not as isolated gatherings, but as pearls aligned in arcs and walls. The more we mapped, the clearer the shapes became. One of the most famous was the Sloan Digital Sky Survey, a project that captured the positions of galaxies across billions of light years. What it revealed was breathtaking, immense filaments stretching across the void, galaxies strung in luminous threads, knots where multiple strands intersected, and vast empty spaces in between. It was as if the universe had been waiting to show its skeleton, and only when we stepped far enough back could we see it. Imagine a pointillist painting where up close you see only dots of color, scattered and meaningless. But from a distance the image emerges structured and alive. The cosmic web is such a painting, written not in pigments but in galaxies, each one a brushstroke of light upon a canvas of darkness. These strings are not delicate ornaments. They are titanic rivers of matter stretching hundreds of millions of light years. Along them, galaxies flow like fish in currents pulled by the gravity of their neighbors and by the mass of unseen dark matter. They migrate, slowly, silently, over billions of years, toward the intersections where filaments knot together. There, clusters of galaxies form, colossal gatherings, each containing thousands of galaxies, gravitational cities at the crossroads of the web. For astronomers, the discovery of this structure was both thrilling and humbling. It meant that the universe was not a scattered field, but an organism with shape, a body with veins and bones. Yet the pattern was not perfectly smooth. Some filaments curved gently, others branched or tangled. Some galaxies stood alone, strays drifting in the emptiness between threads. The web was both ordered and imperfect, a tension between symmetry and variation, like music that repeats but never exactly the same. What does it mean to live inside such a pattern? Our Milky Way is not adrift in isolation. It rests upon one filament of the web, part of a smaller cluster that itself belongs to a larger flow of galaxies. The stars we see each night are not random decorations. They are milestones along invisible highways that stretch into the dark. When you step outside and look upward, you are gazing along one tiny thread of an unfathomable design. And yet, there is wonder in how we first uncovered this. Scientists did not peer into the sky and see threads immediately. They built maps. They took positions, measured redshifts, calculated distances, and patiently assembled a picture. Only when enough points were gathered did the filaments reveal themselves. It was as though the universe required us to earn its secrets, to assemble the puzzle piece by piece, until suddenly the image could no longer be denied. Think of it this way: galaxies are the lamps, but dark matter is the wiring hidden in the walls. We cannot see the wires directly, but the lamps tell us where the circuits run. To map the galaxies is to trace the cables of an invisible architecture, one that connects every shining point to a deeper framework. The lights are only the ornaments, the visible pearls on a necklace spun from unseen thread. If you close your eyes, you can imagine drifting along one of these filaments, your path lined by galaxies on either side, each one a city of stars, each one glowing with billions of suns. The distance between them is vast, but from this vantage they look like beads shimmering along a line of silk. You float for millions of light years, passing clusters that rise like mountains, until the filament thins and emptiness yawns wide. The entrance to a cosmic void. And there, the contrast deepens your awe. Threads against emptiness, light against silence, presence against absence. This discovery that galaxies align into strings reshaped our view of the cosmos. It was no longer enough to study a galaxy alone, as though it were an isolated island. To understand a galaxy, one must understand its neighborhood, its filament, its place in the wider web. Galaxies are not solitary. They are participants in a dance of structure pulled by threads that stretch across the universe. So the night sky, once thought to be scattered dust, reveals itself as a woven design. Galaxies on strings of light, tracing out the shape of something grander, older, deeper. And as we trace those threads, one thought returns, quiet but insistent. If galaxies are the pearls, what of the spaces between? What lies within the empty rooms of the universe, the vast voids where the web falls silent? If the cosmic web is a tapestry, its beauty lies not only in the threads that shimmer with galaxies, but in the spaces between them. To see only the filaments is to miss half the story. Between those threads stretch vast chambers, darker than night, more silent than silence. These are the cosmic voids, empty rooms in the architecture of the universe. Their scales so immense, they dwarf entire clusters of galaxies. Imagine yourself drifting outward from a filament, leaving behind the pearl-like clusters that line the cosmic highways. As you move away, the galaxies thin. The lights grow sparse, then vanish altogether, until you find yourself surrounded by nothing. No stars, no clusters, no faint glow of nebulae. Only darkness upon darkness, stretching in all directions. You are inside a void. It is a place where even imagination falters, for its immensity cannot be contained by human sense. Hundreds of millions of light years across, these voids are not the gaps between things. They are structures in their own right, carved by gravity, shaped by the same forces that give birth to filaments. At first, the mind resists the idea that nothingness can be structure, but the universe insists that it can. The voids are not accidents, not random gaps. They are born from the same ripples that seeded galaxies. Regions that began ever so slightly less dense than their neighbors expanded faster, stretching thin, their matter drawn outward toward the denser threads. Over time, what was once only a small difference became a great one, until the space emptied almost entirely. In this way, absence became a form of presence, and emptiness became its own architecture. Step gently through such a space in your imagination. There is no floor beneath you, no walls around you, and yet you feel the shape of the void, as though it were a room defined not by what it holds, but by what it lacks. Astronomers call them bubbles, cells, cavities in the cosmic foam. Some compare them to soap films, where the filaments form the walls and the voids are the spaces within. In truth, they are not uniform. Some are nearly spherical, others stretched and twisted. Some contain lonely galaxies adrift at the margins, castaways clinging to the edges of emptiness. These isolated galaxies are stories in themselves. Born near the edge of a void, they drift without neighbors, starved of new material, evolving differently from their clustered cousins. They are reminders that even in absence, life persists, even if it flickers faintly. To find such a galaxy is to glimpse solitude on a scale the mind can scarcely hold. Entire civilizations, had they arisen there, might live and die without ever knowing that most of the universe lies elsewhere, strung along threads far beyond their sight. From Earth, we do not see these voids directly. We infer them through maps of galaxies, where clusters outline the edges of darkness. When plotted, the picture is astonishing, an intricate foam of matter and emptiness, filaments tracing the walls of enormous cells. The pattern resembles a honeycomb or the bubbles of froth on the surface of water, and within those cells the voids stretch, silent as sleeping seas. The paradox of the void is this: though they are empty, they give form to everything else. The presence of nothing defines the boundaries of something. The vast cavities are what allow the filaments to stand out, the clusters to shine. In music, silence gives meaning to sound. In art, negative space defines shape. In the universe, voids carve the rhythm by which galaxies gather. Without the emptiness, the fullness could not exist. Drift deeper, and the void begins to feel almost alive. Not alive with galaxies, for they are nearly absent, but alive with expansion. The emptiness itself grows. As dark energy accelerates the universe, voids expand faster than the dense regions, swelling like lungs filled with breath. Filaments retreat, walls thin, and the rooms of the cosmos grow larger still. In this way, the universe becomes ever more a kingdom of emptiness, with light confined to its delicate threads. And here, in this silence, a strange comfort arises. For though the void is vast and indifferent, it is also gentle. There are no cataclysms here, no violent collisions of clusters, no starbursts igniting in clouds of gas. There is only stillness, an endless horizon of quiet. To imagine resting here is to imagine a peace so deep it dissolves thought itself, leaving only the awareness of being suspended in nothingness. Perhaps, in some way, the void is not frightening but consoling, a reminder that even the universe has places where it rests. Yet questions linger. If these voids dominate the volume of the cosmos, what mysteries might they hide? Could they contain the faint signatures of unknown physics, subtle imprints of dark energy's work? Might they whisper clues about the earliest moments, fossil traces of the universe's expansion etched in emptiness? Some scientists suggest that voids may be the purest laboratories, their quiet untouched by the noise of galaxies, their silence capable of carrying secrets across time. As you hold this image, the balance of the universe comes into view. Threads and voids, light and silence, presence and absence, woven together in a design that cannot exist without both. The filaments shine only because the voids allow them space to stretch. The voids expand only because the filaments anchor them in contrast. Together they write the rhythm of the cosmos, a pattern of fullness outlined by emptiness. And so when you gaze at the night sky, remember that most of the universe is not the stars but the silence between them. Remember that what we see is only the embroidery, while the fabric itself is emptiness. Remember too that this emptiness is not meaningless. It is the stage, the canvas, the breath between notes. It is the architecture of absence shaping the presence of everything we hold dear. And as you rest in that thought, let this question drift gently across your mind. If the universe needs its vast silences to give meaning to its lights, then what role does emptiness play in our own lives? Can the quiet between moments, the pauses between words, also be part of a greater design? If the universe is a tapestry, then gravity is the loom. It is the force that pulls the threads taut, guiding the weave with a patient and invisible hand. Without it, matter would have remained a drifting haze, a mist without pattern, a sky with no stars. With it, the universe found structure. Out of silence, a design emerged. Imagine the earliest moments after the Big Bang, when the cosmos was still glowing, filled with a nearly uniform fog of particles and light. At first glance, it seemed smooth, without distinction, like a calm sea stretching forever. But hidden within that sea were ripples, slight variations in density, tiny fluctuations born from quantum uncertainty. They were so small, almost imperceptible. Yet gravity listened to those whispers. Wherever matter was just a little denser than average, gravity began to pull more strongly, coaxing other particles closer. Over eons, these subtle attractions grew. What was once a faint difference became a gathering, then a flow, then a current. Gas drifted along invisible paths, dark matter deepened the channels, and the universe began to shape itself into rivers and knots. Filaments stretched, clusters thickened, and the first stars found their places within this unseen geometry. Gravity had turned chance into pattern, chaos into form. Close your eyes and imagine gravity not as a force, but as a weaver at a loom. With every pull, it tightens a thread. With every knot, it binds galaxies together. It does not rush, for it works in cosmic time. 1 billion years are but a breath. A galaxy cluster is but a bead threaded onto an endless cord. The loom never stops, never tires, never falters. It is steady, precise, and utterly silent. One of gravity's most remarkable qualities is its invisibility. You cannot touch it, cannot see it, cannot bottle it, yet it governs everything. It binds planets to stars, stars to galaxies, and galaxies to filaments. It reaches across billions of light years without weakening, shaping the architecture of the cosmos with a patience beyond comprehension. In its silence lies its strength. Without ever announcing itself, gravity decides the fate of stars and the destiny of worlds. Consider the filaments of the cosmic web. They are not random alignments of galaxies, but rivers drawn by gravity's hand. Dark matter, unseen but immense, creates the scaffolding. Ordinary matter, gas, dust, and light follows like colored threads wrapped around an invisible frame. As gas flows inward along the filaments, it fuels galaxies, feeding them with the raw material of stars. Without gravity's gathering, these galaxies would starve, adrift, and fading in isolation. And yet, gravity is not only a builder, it is also a sculptor. It pulls matter inward, but it also defines boundaries. At the edges of voids, gravity outlines the walls. In the depths of clusters, it binds thousands of galaxies into a single, massive city of stars. Even black holes, the most extreme expressions of gravity, are woven into the design. Their immense pull carves out the centers of galaxies, regulating their growth. Gravity threads order into every scale, from the swirl of a spiral galaxy to the span of the observable universe. There is a paradox here. Gravity, the weakest of the four fundamental forces, is also the most commanding. It cannot be shielded, cannot be turned off, cannot be escaped. The same force that holds your body to Earth reaches across the void to pull galaxies into clusters, superclusters, and beyond. It is the great connector, the invisible loom upon which all patterns rest. Imagine drifting along a filament in your mind. Galaxies stretch before you like glowing beads on a string, each one a jewel bound to its path by gravity. The thread is not visible, but you sense it. An unseen current flowing beneath the stars, a quiet tide carrying them along. If you pause to listen, you almost hear it. Not a sound, but a rhythm, the steady heartbeat of attraction and release. Astronomers map this rhythm by observing the distribution of galaxies. When they plot them across vast distances, a hidden order appears. Filaments stretch like highways, knots form at intersections, and voids bloom between them. This is not chance. It is gravity's design, the long patient work of the loom. Yet the loom is not finished. Even now, gravity continues its weaving. Galaxies fall into clusters. Clusters merge into superclusters. Filaments pull tighter, and voids expand. The cosmic web is alive, growing, changing, shifting. And though dark energy drives the expansion of space itself, gravity resists, knitting matter together even as the universe stretches apart. The dance between gravity and expansion writes the future, a balance between holding close and letting go. There is something deeply poetic in this, for gravity does not create from nothing. It works only with what exists, gathering, folding, binding. It does not impose order from outside, but draws it forth from within, like a sculptor revealing the figure already hidden in the stone. The universe was always capable of this design. Gravity merely showed it the way. Perhaps this is why, when we look at the stars, we feel a strange kinship with them. For we too are bound by invisible forces pulled toward one another, shaped by unseen connections. Families, communities, memories, loves, all woven into patterns by forces that cannot be touched, but are deeply felt. Gravity is not only the universe's loom, it is a metaphor for our own lives, and so as you picture the cosmic web stretching through the dark, remember that every glowing thread, every shining cluster, every solitary star owes its place to gravity. Without its patient weaving, there would be no filaments, no galaxies, no Earth, no you. Only mist drifting forever, patternless and forgotten, but gravity wove, gravity bound, gravity shape. And in that weaving, it gave the universe not just structure but story. In the theatre of the night sky, what we see is dazzling. Stars, galaxies, rivers of light. But what we see is not the whole. It is only the surface, the shimmer, the visible paint on a much larger canvas. Beneath it lies something stranger, quieter, and infinitely more mysterious. Dark matter. It does not shine, it does not glow, and it does not speak in the familiar language of light. And yet, it is there, forming the hidden skeleton upon which the cosmos depends. Without dark matter, the filaments of the web would fray. Galaxies would not cling to their strings, clusters would unravel, and the universe would lack its bone. Dark matter does not simply participate in the structure of the cosmos. It is the structure. It is the scaffolding, the unseen lattice that holds everything else in place. The story begins in the early universe, when gas and radiation still dominated. Ordinary matter, the atoms we know, tried to clump together, but photons scattered them apart, keeping them restless. Only dark matter, immune to light, could gather freely, forming the first invisible wells of gravity. Into these wells, gas eventually fell, cooled, and gave rise to stars and galaxies. The skeleton was laid first, the flesh followed later. Without dark matter, there would be no galaxies at all. Only a thin fog of atoms, spread too evenly to ignite the brilliance we now see. Imagine walking through a cathedral built entirely of glass. You marvel at the soaring arches, the intricate windows, the patterns of light spilling across the floor. But unseen beneath that beauty are the beams, the framework that holds it all steady. Remove the beams and the cathedral collapses into shards. Dark matter is those beams. Silent, invisible, yet indispensable. It is the architecture beneath the spectacle, and yet what is it? Here lies the great puzzle. Dark matter makes up most of the matter in the universe, yet it has never been touched, never been captured, never been seen directly. We know it is there only by its pull, by the way galaxies spin and bend light in its presence. If a galaxy is a lantern glowing in the night, dark matter is the unseen hand that steadies it, keeping its flame from scattering in the wind. Astronomers first began to sense this hidden substance when they noticed galaxies behaving strangely. Stars at the edges of spirals were moving far too fast, as if something massive and invisible were holding them in orbit. Without that unseen mass, those stars would fly away into the dark. Later, clusters of galaxies showed the same mystery. Light passing through them bent more than expected, as though an unseen weight were pressing down on space itself. The conclusion was inescapable. The cosmos was full of something we could not see. Close your eyes and imagine drifting through one of these clusters. Galaxies glitter like jewels, but you sense another presence, vast and ghost-like, surrounding them. It has no color, no shimmer, no voice, and yet you feel its outline. A soft but insistent gravity shaping the paths of galaxies, anchoring them to the web. You cannot see the bones, but you know the body could not stand without them. Some theories suggest that dark matter is made of particles unlike any we have known, interacting only through gravity. Others imagine more exotic possibilities. Hidden dimensions, fields beyond our comprehension, echoes of a deeper physics not yet revealed. In laboratories deep underground, scientists build detectors waiting for a whisper of contact, a passing trace of this ghostly substance. But so far, it remains beyond our reach, a secret the universe keeps close, and there is something humbling in that secrecy. We who measure the light of distant stars and weigh the mass of galaxies must admit that most of the cosmos is invisible to us. What we see, all the stars, planets, nebulae and galaxies, is only a fraction. The rest is shadow, scaffolding, skeleton. The stage lights dazzle, but the theatre itself is built of dark matter. Yet the mystery is not absence. It is presence in another form. For though dark matter is hidden, its influence is everywhere. Every galaxy is a lantern hung upon its frame. Every filament is a rope wound tightly with its strands. Every void is defined by the walls of dark matter that surround it. We do not see it directly, but we live within its architecture, like fish unaware of the sea. There is a beauty in this, that the most essential structures are the ones we cannot see. The web of dark matter is like the roots of a forest, buried beneath the soil, unseen yet nourishing all life above. The stars are only the leaves flickering in the wind. The skeleton beneath is what endures. Perhaps this is why the thought of dark matter feels almost spiritual. It invites us to accept that not all truths are visible, not all presences are lit. Sometimes the most powerful realities are those we sense only through their effects, their echoes, their quiet insistence. The cosmos teaches us humility, to trust what we cannot see, to believe in the strength of what is hidden. And so, when you gaze into the night sky, remember that the stars you see are not alone. They are cradled, supported, and shaped by a ghostly framework that stretches across the universe. Dark matter's skeleton is vast, silent, and enduring, holding galaxies as gently as bones hold a body. What, then, is the nature of this hidden skeleton? Is it a shadow of something deeper, a clue to a physics beyond our reach, or simply the quiet foundation upon which all else rests? The answer remains out of sight, waiting in silence. Perhaps that is fitting. For every skeleton, no matter how strong, is meant to remain unseen, supporting the body without ever demanding the light. When faced with the invisible, we instinctively reach for light. It is our most faithful companion, the messenger that travels across billions of years to bring us news of distant places. Without it, the universe would remain silent, unknowable, a darkened stage with actors we could never see. With it, the cosmos becomes a story slowly unfolding, written in beams and echoes. To map the unseen skeleton of the universe, astronomers needed a cartographer, and they found it in light. Imagine the universe as a parchment stretched vast and endless, waiting to be inscribed. The ink is not black, but radiant. Galaxies, stars, and the faintest whispers of background radiation become the pen strokes. Over time, an image develops, like a photograph rising from blankness in the quiet of a dark room. Slowly, the outlines of the cosmic web appear, traced not by human hands, but by the paths of photons. The first step was to understand how light changes as it journeys. Every galaxy that drifts away from us leaves a signature. Its light stretches, its waves elongate, shifting toward red. This is the redshift, the silent testimony of expansion. By measuring this stretching, astronomers discovered not only how fast galaxies are receding, but also where they are placed in the vast three-dimensional map. Each redshift is a coordinate, a marker on the parchment. Piece by piece, the invisible lattice of the universe began to take shape. In the middle of the 20th century, ambitious surveys set out to chart the heavens in this way. Telescopes scanned thousands, then millions of galaxies, each plotted by its redshift, each becoming a point of light in a cosmic atlas. At first, the maps looked random, a scatter of dots across the page. But as more points were added, a pattern emerged. Filaments, clusters, walls, and voids revealed themselves like veins beneath translucent skin. The universe was not chaos. It was design. Still, redshift surveys told only part of the story. To trace the very first threads, astronomers turned to a much older messenger, the cosmic microwave background, the afterglow of the Big Bang. This faint radiation, stretched to microwaves by billions of years of expansion, fills all of space. At first glance, it seems uniform, a soft glow bathing the universe evenly. But with sensitive instruments, astronomers detected tiny variations, ripples in temperature as small as a few parts in 100,000. Those ripples were not random blemishes. They were the imprints of the first structures, the fingerprints of quantum fluctuations magnified by cosmic inflation. Each warmer spot marked a region of slightly higher density, each cooler patch a place of slightly less. In those minute differences lay the seeds of filaments, voids, and clusters yet to come. The microwave background was not just light. It was memory, the universe's baby photograph. And in it, astronomers found a map of the invisible future, a blueprint for the cosmic web. Think of it as standing before a frozen pond in winter. At first, the ice seems smooth, blank, featureless. But step closer and faint patterns emerge. Hairline cracks, delicate ridges, subtle swirls. They are signs of stresses and currents hidden beneath the surface. So too with the cosmic microwave background. Beneath its uniform glow lie the subtle currents that shaped everything to come. Together, redshift surveys and background maps transformed light into a cartographer's tool. One revealed the present web in its vast expanse. The other revealed the primordial sketch from which it grew. Between them lies a conversation across time, the early ripples that predicted the later filaments, the skeleton imagined long before it matured. The invisible became legible, a design traced in photons. Yet light's role as cartographer is not only technical, but poetic. It teaches us that to know the hidden we must look for echoes. To understand the skeleton we must study the shadows it casts. Dark matter itself may remain invisible, but the galaxies it shepherds glow, and in their glow we glimpse the hand that guides them. Gravity may be silent, but the bending of light betrays its presence, warping images into arcs and rings that whisper of mass we cannot see. The cosmos may be written in darkness, but it reveals itself in radiance. Close your eyes and imagine drifting through a map of galaxies, each one a dot of light positioned by its redshift. The filaments stretch before you like glowing threads, while voids gape like empty rooms between them. It feels like navigating a vast city by night, where the lit streets reveal the structure, even though the buildings themselves fade into shadow. You do not need to see every wall to know the design. The light alone sketches the outline. And just as ancient cartographers once drew coastlines by tracing the paths of ships, so astronomers now draw the universe by tracing the journeys of photons. Each photon is a traveler, carrying in its wave the memory of its origin. Some have crossed billions of years to reach us, unbroken, unchanged, still faithful to the pattern from which they came. We collect them tenderly like messages in bottles washed ashore, and from them we compose the maps of all that is. There is a humility in this practice, for light does not give up its secrets all at once. It must be gathered patiently, interpreted carefully, trusted as both witness and guide. And just as maps are never the territory but only its sketch, so too are these luminous atlases only approximations of the real, deeper structure. Yet they are enough to show us that the universe has bones, that the invisible is not chaos but architecture. What does it mean that light, so delicate, so easily absorbed or scattered, has become our most faithful guide? Perhaps it means that fragility itself can be enduring, that even the faintest signal, if carried faithfully through time, can reveal the greatest truths. And so the map grows. Each survey adds more dots, each new telescope draws sharper filaments, each refinement reveals more of the hidden skeleton. The cartography of the cosmos is far from finished, But already the outlines are clear. The web stretches vast, the voids are immense, and the invisible has been traced by light into something we can begin to know. Still, the deeper mystery lingers. Light shows us the map, but what is the substance of the web it sketches? What truly fills those filaments, and how do unseen rivers flow along them? The cartographer reveals, but the story it points toward has only begun. Before the universe was transparent, before stars lit their first flames, there was sound. Not sound as we hear it on Earth, carried through air and heard by ears, but vast acoustic ripples moving through a dense, hot plasma of particles and light. The early cosmos was a resonant chamber, vibrating with pressure waves, a kind of music born not of strings or wind, but of gravity and radiation. And though the sound itself faded long ago, its echoes remain, frozen into the great cosmic web, like a melody impressed into stone. Close your eyes and imagine the universe not as silent, but as a sea of tones. In those first hundreds of thousands of years, matter and radiation were tightly coupled, moving together like dancers in a crowded hall. Gravity pulled matter inward, trying to gather it into clumps, but radiation pushed outward, resisting compression. The result was oscillation. Inward pull, outward push. A rhythmic pulse that swept through the young cosmos. The universe was playing chords upon itself, resonating with waves that traveled vast distances across the primordial plasma. These were the baryon acoustic oscillations, ripples of density and pressure that expanded like sound waves in an enormous fluid. If you could have floated there, you would not have heard them with ears, for there was no air, no familiar medium of sound. But you might have felt them as the very space around you throbbed with pressure waves, a symphony of expansion and resistance, of compression and release, filling the cosmos with rhythm. And like any symphony, these waves left structure behind. Regions compressed by gravity became denser. Regions expanded by radiation became thinner. Over time, these patterns froze, imprinted into the distribution of matter. What began as oscillations in plasma became the scaffolding of galaxies and clusters. The music did not vanish. It crystallized into architecture. The score was written not in notes, but in filaments and voids. Astronomers today detect these ancient harmonies in the clustering of galaxies. When they measure the spacing between galaxies on the largest scales, a subtle pattern emerges. Galaxies are slightly more likely to be separated by a certain distance, a remnant of those early pressure waves. It is as though the cosmos, long after the orchestra fell silent, still carries the rhythm of its first performance. The baryon acoustic oscillations are the lingering resonance, the faint but measurable chords of the newborn universe. Think of it as striking a bell. The sound fades quickly, but the vibrations linger, leaving faint patterns in the metal. The universe was such a bell struck at birth. Its ringing did not carry into eternity as sound, but as frozen ripples in the distribution of matter. When we look across billions of light years and trace the filaments of galaxies, we are seeing the bell still humming, its song etched into space itself. The cosmic microwave background offers another record of this music. Its subtle ripples in temperature, mapped with exquisite precision, are the frozen peaks and troughs of those early oscillations. Each bright spot marks a crest of compression, each dim spot a trough of rarefaction. Together, they are the sheet music of the first great symphony, written in photons instead of ink. By studying these patterns, astronomers can reconstruct the harmony that once filled the cosmos, measuring the pitch and tempo of the universe's earliest rhythms. And what is most astonishing is how orderly it all is. These were not chaotic sounds, but harmonious ones, repeating with regularity across scales. The oscillations moved outward like ripples from a stone tossed into a pond, each ripple marking a predictable distance. Billions of years later, we can still measure that distance in the arrangement of galaxies, like archaeologists uncovering the notes of an ancient song carved into stone. There is something deeply poetic in the idea that the universe began not only with light, but with music. Creation itself was rhythmic, resonant, filled with a pulse that carried across time. And though our ears cannot hear it, our instruments can detect its traces, our minds can imagine its song. The cosmos is not just a place of silence and emptiness, but one that once rang with pressure and sound, a chorus of matter and radiation weaving together in harmony. Perhaps this is why music feels so fundamental to us. Its rhythms echo something older than humanity, older than Earth, older even than stars. When we hear a drum beat or a chord, when we feel the swell of an orchestra, perhaps we are remembering in some deep way the first symphony ever played, the oscillations of the cosmos itself. Music so vast, so encompassing, that it wrote the very structure of the universe, and yet the song continues in a way. The oscillations themselves froze when the universe became transparent, when photons broke free to travel on their own, but their patterns remain, etched into the web of galaxies, into the afterglow of the Big Bang. To study them is to listen across time, to place one's ear against the fabric of space and hear the distant ringing of creation. If you step back, far enough to see the cosmic web as a whole, the symmetry is striking. Filaments align like the strings of an instrument, voids gape like pauses between notes, clusters gather like chords at points of convergence. The entire universe becomes a score, not random, but composed, each structure a remnant of an ancient rhythm, and so we are left with an image, the cosmos as symphony, matter as instrument, gravity and radiation as musicians, time as the conductor. The performance ended billions of years ago, yet its resonance still shapes everything we see. The great cosmic symphony is both past and present, both silence and sound, both memory and reality. The question lingers, if the universe began with music, does it still sing in ways we have not yet learned to hear? Are there harmonies beyond baryon oscillations, rhythms deeper than our instruments can trace? Perhaps creation is still resonating in tones we will someday discover, waiting for us to join the audience. Stand at the edge of the cosmic web, and you face a paradox. The universe is endlessly vast, yet strangely familiar at every scale. Zoom outward to billions of light years, and you see filaments of galaxies woven into a lattice of clusters and voids. Zoom inward to clouds of dust and gas within our own galaxy, and you find tendrils and knots that resemble the same filaments. Zoom further still, down to the branching structures of molecules, and the echoes remain. The universe, it seems, loves repetition. It draws with the same hand across scales, whispering symmetry in patterns we call fractals. A fractal is more than a shape. It is a principle. The idea that a structure can look similar no matter how closely you examine it. Think of the branching of a river delta. From above, the great channels split and wind like veins. Look closer, and each branch splits again, smaller but similar in form. Closer still, even the tiniest rivulets echo the larger curves. The whole is mirrored in its parts, and the parts echo the whole. That is the essence of fractals. When astronomers first mapped the distribution of galaxies, they were startled by how this fractal quality seemed to emerge. Clusters of galaxies gathered into superclusters, which stretched into chains, which wove into sheets and filaments. The web did not smooth out quickly, as one might expect from a random distribution. Instead, it revealed structure at scale after scale, as though the universe itself were a grand Mandelbrot set written in matter and light. Consider the branching patterns of interstellar clouds. Within the Milky Way, vast molecular clouds stretch for hundreds of light years, filled with cold hydrogen gas. Viewed in radio light, they appear as tangled threads, twisting and splitting like the roots of an ancient tree. Within these filaments, smaller knots form which collapse into stars. Within those stars, nuclear chains unfold, building the atoms that will someday form planets, rivers, and trees. The symmetry loops back. Clouds birthing stars, stars birthing matter, matter forming beings who gaze outward and notice the echoes of the original clouds. It is as if the universe cannot help but repeat itself. The branching of lightning across the sky resembles the branching of neurons in the brain. The swirls of hurricanes mirror the spirals of galaxies. The rippling dunes of sand resemble waves on the sea, which in turn resemble ripples in space-time. Across nature, across scale, the same motifs appear: branching, spiraling, clustering, webbing. Fractals are not just abstract mathematics. They are the preferred language of creation, and the cosmic web itself is perhaps the grandest fractal of all. Imagine zooming out from Earth, the solar system, with its planets orbiting like beads on invisible threads. The Milky Way, a spiral with arms curling outward like fern fronds. Beyond, the local group of galaxies bound together like a cluster of leaves on a stem. Beyond that, filaments of superclusters, stretched like roots and veins across billions of light years. Each step outward reveals new structures, yet each new structure feels like an echo of the last. Scientists debate how truly fractal the universe is. On very large scales, beyond a few 100 million light years, the cosmos does smooth into near uniformity. The cosmic microwave background shows us that at its birth, the universe was astonishingly even. But in the middle ground, across the scales of galaxies, clusters, and filaments, fractal-like organization dominates. Patterns repeat, not perfectly, but rhythmically, like variations on a theme. Enough to suggest that self-similarity is written into the physics of structure itself. Fractals often arise from simple rules applied again and again. The branching of a tree comes from a seed's DNA repeating growth instructions at each level. The swirls of a storm form from air, obeying simple fluid dynamics, spiraling under rotation. Perhaps the cosmic fractal emerges in the same way, gravity pulling matter together, expansion stretching it apart, the two forces playing their simple game across infinite scales. The outcome is complex, but the rules are simple, and simplicity repeated is the root of fractal beauty. For us, there is something profoundly satisfying in this repetition. To find that the vastness of the cosmos echoes the smallness of our world gives a sense of unity. It dissolves the boundaries between micro and macro, between human and cosmic. The same patterns that shape the rivers and trees around us also sculpt the filaments of galaxies billions of light years away. The universe is not alien, it is kin. Some have suggested that consciousness itself may be fractal. Neurons branch like lightning, and networks of neurons mirror the structures of social networks, which in turn echo cosmic webs. It may be that the mind is tuned to recognize fractals because it, too, is built upon them. To see fractals in nature is in some sense to see the architecture of thought itself projected onto the world, and so, when we gaze at the cosmic web and marvel at its resemblance to neural networks or tangled roots, perhaps it is not coincidence. Perhaps the fractal is the bridge between mind and cosmos, the common geometry that allows us to see the universe and feel, instinctively, that it is alive with pattern at the deepest level. Fractals remind us of infinity. No matter how far you zoom in, the pattern continues. No matter how far you zoom out, new echoes appear. Infinity is not only in size, but in repetition, in the endless unfolding of form upon form. The universe does not simply exist. It repeats, recycles, mirrors itself, as though creation were practicing a song with infinite verses. So close your eyes and imagine. The universe is a vast tapestry of self-similarity, woven with repeating motifs. Galaxies as spirals of hurricanes, hurricanes as spirals of seashells, filaments of galaxies as veins of leaves as rivers branching across continents. Everywhere you look, the echoes return. Everywhere you look, the infinite repeats, fractals in the infinite. Not just shapes in space, but whispers of unity, a reminder that everything belongs to the same design. The great and the small are not separate, but verses of the same poem. Imagine holding a tapestry in your hands, woven not of fabric, but of moments. Each thread is an age of the universe, each knot a turning point in cosmic history. The cosmic web is not still, not frozen like a photograph pinned in place. It is alive with motion, stretched and reshaped by the great forces that govern space itself. To drift through it is to drift not only through distance, but through time. You are carried forward and backward, watching the filaments shift, merge and unravel as the universe tells its story across billions of years. In the beginning, the threads were faint. After the Big Bang, the universe was a hot and glowing ocean, smooth with only the faintest ripples. Those ripples were seeds, variations in density no larger than 1 part in 100,000. Yet even then they were the whispers of the web to come. Under gravity's pull, these ripples deepened. Tiny overdensities grew into knots, and knots pulled in more matter, forming filaments like strands of silk stretching across a darkening sky. The first billion years were a time of gathering. Hydrogen cooled, stars ignited, and galaxies spun themselves into being along the filaments. The web became visible in light for the first time, glowing as galaxies clumped like beads along invisible threads. Expansion continued, but gravity worked in opposition, binding matter together, preventing it from being torn into perfect smoothness. What emerged was not chaos, but pattern. Not disorder, but design. The cosmic web revealed itself as both an artwork and a process, as if the universe were both artist and canvas. As ages passed, the threads thickened. Filaments fed galaxies with streams of cold gas, the raw material for stars. In this way, the web was not just a scaffold, but a lifeline, a system of arteries pumping matter into luminous islands. Clusters grew heavy at the intersections, knots tightening under gravity's hand. Some filaments stretched taut between them, while others merged, weaving denser highways across the cosmos. The web shifted like a living body, reshaping itself, yet always retaining its essential pattern: filaments, knots, and voids. But change was not only born of gravity. Another force emerged to complicate the dance: dark energy. For billions of years, gravity held sway, gathering and weaving. Then, about 5 billion years ago, expansion began to accelerate. Dark energy, invisible and mysterious, pushed space apart at an ever-increasing rate. The web still grew, but its growth slowed, its filaments stretched thinner by the accelerating fabric of the cosmos. Gravity pulled inward, dark energy pressed outward, and the tension between them began to write the next chapter of the universe's evolution. This tension is the essence of time's threads. Gravity seeks coherence, knitting matter together, sculpting stars and galaxies into knots of structure. Dark energy seeks dispersal, a quiet undoing, an outward drift. The two forces do not cancel each other, but create a dynamic balance that shifts with every age. Without gravity, the universe would be nothing but featureless emptiness. Without dark energy, it might collapse under its own weight. Together, they create a cosmos that evolves, never static, never finished. As you float through the cosmic web in imagination, you can see this tug-of-war. Filaments lengthen like bridges stretched across widening valleys. Knots of galaxies cluster tighter, fed by streams that thin with time. Voids swell, their emptiness expanding faster than matter can fill them. What once was dense and close becomes more tenuous, more fragile, yet still patterned. The web endures, but its shape is rewritten with every passing billion years. Astronomers peer into this unfolding with their telescopes, which are not only machines of light, but machines of time. To look deep into space is to look back into history. The farthest galaxies appear as they were billions of years ago, when filaments were younger, when knots were smaller, when the balance between gravity and dark energy was tilted toward gathering rather than dispersal. By stitching these snapshots together, scientists reconstruct the motion of the threads, watching the tapestry evolve frame by frame. And the story does not end in the present. Project the forces forward, and the threads of time continue their work. In the far future, clusters of galaxies will remain bound together by gravity, but separated ever more from their neighbors. Filaments will thin until they are faint whispers. The cosmic web, once vibrant and tightly knit, will stretch into a more isolated, quieter pattern. The night skies of distant civilizations may reveal fewer galaxies, fewer traces of the great architecture. The story of the web will still exist, but it will be harder to read. This, too, is part of the beauty. The web is not permanent. It is a living design, shifting with the ages. Like a melody that changes as it is played, it cannot be frozen without losing its essence. The very act of stretching and reshaping is what makes it real. To see the threads of time is to accept that the cosmos itself is a river carrying everything forward, binding past and future into a single flowing pattern. And so you are left with this vision. A universe that weaves itself endlessly, gravity tying knots, dark energy loosening them, filaments stretching, clusters thickening, voids expanding. The web evolves, never finished, never still. You drift through it as a traveler not only of space, but of time, feeling the threads brush softly against you, each one humming with the story of an age. If the cosmos is a tapestry, then time is the weaver's hand. The question lingers: what new patterns will it create as the loom of the universe continues its endless work? When the eye can no longer see, when telescopes reach the horizon of their power, the imagination must take a new form. For astronomers and physicists, that imagination has become digital. Vast universes created not with clay or paint, but with numbers, equations, and code. Inside supercomputers, scientists build realities that never existed in stone or sky, yet mirror the cosmos with astonishing accuracy. These are not mere pictures, but living simulations, places where billions of particles move, collide, and gather, revealing the hidden skeleton of the universe. Imagine standing before such a machine. Its towers hum with quiet power, thousands upon thousands of processors working in unison, their rhythm a kind of heartbeat. Into it goes the mathematics of gravity, the expansion of space, the physics of gas and light. Out of it emerges a universe, dark matter flowing like ink into filaments, galaxies forming like dew along threads, voids yawning open like quiet valleys. It is as though the cosmic web has been captured in a time lapse, a slow eternity condensed into frames that flicker across a screen. The first of these simulations were modest, simple attempts to let a handful of particles evolve under gravity. Even so, they hinted at the elegance of the web. Clumps formed, filaments stretched between them, patterns emerged that felt familiar. But as computers grew stronger, the simulations swelled in scale. What began with thousands of particles grew to millions, then billions. Today, the greatest simulations track more particles than there are stars in our galaxy, mapping structures on scales impossible for human minds to picture without assistance. Take the Millennium Simulation, for instance, one of the landmark projects. It filled a cube of virtual space 2 billion light-years wide with 10 billion particles of dark matter, each moving under the pull of gravity. From a formless scatter, order emerged, filaments, clusters, and voids, all resembling the universe we observe. Later simulations added even greater detail, weaving in gas physics, the birth and death of stars, the outflows from black holes. What appeared on the screen was not only structure, but life. Galaxies forming, colliding, growing luminous as though the machine itself were dreaming creation. To drift inside one of these simulations is to drift through a ghost universe. You watch as time accelerates. Billions of years pass in seconds, filaments stretch like taffy, clusters swell and merge, voids open wider. The cosmic web breathes in slow motion, expanding outward as though you were watching the universe inhale and exhale. Every frame tells a story of balance. Gravity drawing matter inward, dark energy pushing it apart, stars igniting, galaxies drifting. It is the same dance as the real cosmos, but sped up, illuminated, made visible to our limited eyes. What makes this so powerful is not only the beauty, but the insight. Simulations allow us to test ideas about the universe itself. What happens if dark matter behaves differently than we think? What if dark energy evolves with time? What if galaxies feed less efficiently on the gas of their filaments? In these digital worlds, the laws can be rewritten, adjusted, and compared against reality. By matching the simulated web to the one we observe through telescopes, scientists refine their understanding, bringing theory and evidence into harmony, and yet, there is something poetic about these efforts too. We build miniature universes to better understand our own, but in doing so, we also confront the mystery of creation. Each simulation begins with a kind of digital Big Bang, a formless scatter of particles seeded with fluctuations. Then time is allowed to run, and order blooms from chaos. Watching it unfold, one cannot help but wonder whether our universe itself is such a simulation, whether we too are part of a grand computation playing out on some unimaginable machine. The simulations we build reflect not only the cosmos, but our own desire to mirror it, to contain infinity within circuits and code. Inside these simulated webs, beauty repeats itself. Whether the scale is millions of light years or just a few, the same filaments and voids appear, the same fractal symmetry emerges. It is as though the computer is confirming what our telescopes already suggest, that the design of the cosmos is not random, but patterned, recursive, endlessly self-similar. And in seeing this repetition, we glimpse not only the physics, but the poetry of creation, where the same brushstroke is painted across scales both small and vast. But perhaps most striking is the sense of time compressed. What took the universe 13 billion years to weave, a supercomputer can unfold in days or weeks. We are granted a vision impossible in nature, to see the birth, growth, and destiny of galaxies in a single sweep. Time becomes pliable, a ribbon rolled forward and backward at will. By playing with it, scientists glimpse futures yet to come, projecting how the web will stretch under the influence of dark energy, how clusters will separate, how the pattern will fade into distance, and so simulations are not only mirrors of the past, but windows into possibility. They allow us to wander through universes that never were, to test the fabric of reality with imagination sharpened by mathematics. They give us the gift of vision where eyes alone would fail. They are both tools and metaphors, reminding us that the cosmos itself is a computation, an unfolding of laws written into the fabric of existence. As you picture this, imagine yourself not outside the simulation but within it. You float among filaments of light that stretch across the screen, galaxies blooming around you like luminous flowers. With each step forward, billions of years pass. With each pause, you watch eternity condense into a moment. The hum of the supercomputer becomes the hum of the cosmos itself, circuits echoing the resonance of galaxies. In this silence, in this machine-made dream, you glimpse the invisible map of the universe brought into clarity. The question lingers as the simulation fades. Are we merely mapping the cosmos, or are we learning to recreate it? Imagine holding two images side by side. On one, the vast expanse of the universe, galaxies strung like pearls along glowing filaments, dark voids stretching between them like silent oceans. On the other, the delicate branching of neurons in the human brain, axons and dendrites weaving together, connecting, firing, carrying thought across the spaces between. At first glance, the scales are unimaginably different, one measured in light years, the other in microns. And yet a quiet resonance stirs. The shapes echo one another. The patterns whisper of kinship. The cosmic web is the largest structure known, but it is not unique in its geometry. Nature repeats forms across scales as though a single brush paints both the infinite and the intimate. Neurons branching in the cortex mirror the great filaments of galaxies. Mycelium threads beneath forests, hidden but vital, resemble the connective tissue of the cosmos. Rivers on Earth carve landscapes into winding paths that branch, divide, and converge again, a reflection of how matter flows along invisible highways in space. Even lightning streaking across a stormy sky follows fractal routes, like brief filaments of energy mimicking the long-lived filaments of matter. These parallels invite wonder. Could it be that the same principles shape both neuron and galaxy? That the dance of branching and connecting is not random, but a universal tendency of systems seeking efficiency, balance, and flow? In the brain, neurons form networks that minimize energy while maximizing connection. In the cosmos, galaxies gather along filaments that channel gas with the least resistance, feeding stars in the most efficient way. Different in substance, yet similar in form. The pattern may be the principle. Scientists and philosophers alike have lingered on this resonance. The cosmic web has been called the universe's brain, a mind written in light. Not because it thinks as we do, but because its architecture recalls our own neural networks. Some simulations even suggest that the distribution of galaxies and the distribution of neurons share statistical similarities, as though nature recycles its geometry when weaving complexity. In this view, the microcosm and macrocosm are mirrors, each reflecting a truth about the other. But perhaps it is not only neurons. Consider mycelium beneath the soil, the hidden fungal networks that allow forests to whisper to themselves. Trees exchange nutrients, send signals of distress, share strength in times of need, all through a subterranean lattice. The shape of this lattice, fine threads branching and reconnecting, mirrors the cosmic filaments above. Both are invisible until revealed with patience and the right instruments. Both sustain life, one feeding galaxies with gas, the other feeding roots with minerals. One operates across billions of light years, the other within a forest floor. Yet both create hidden maps of connection, unseen but essential. Water too takes up this pattern. Rivers carve channels that split and merge, their branching resembling blood vessels, root systems, lightning bolts, even the distribution of dark matter. At every scale, nature favors branching as a way of moving matter and energy. It is as though the universe itself prefers this geometry, a path of least resistance, a compromise between spreading wide and staying connected. When you look at a river delta from above, you are looking at an echo of the same geometry that arranges galaxies. This symmetry across scales is more than coincidence. It may be a window into universal laws, systems governed by flow, whether of water, energy, information, or matter, often evolve toward similar branching structures. Efficiency demands it. Stability demands it. In this way, neurons, rivers, mycelium, and galaxies are not simply similar by chance, but by necessity. They are solutions to the same problem: how to connect many points with minimal cost, how to balance expansion with cohesion. Yet there is also poetry here, beyond mathematics. To gaze at the cosmic web and then at the human brain is to feel a kinship between ourselves and the cosmos. The same patterns that fire thought in your mind also string galaxies across the void. The same geometry that lets forests breathe also lets clusters form at cosmic intersections. We are not separate from the universe. We are reflections of it, mirrors of its logic and rhythm. In this resonance, philosophy finds fertile ground. If the brain resembles the cosmos, does the cosmos, in some sense, resemble a brain? If the web sustains galaxies the way neural networks sustain thought, might the universe itself be carrying something like memory, something like awareness? Or are we simply pattern-seeking beings projecting minds into stars? The question lingers, unsolved, perhaps unanswerable, yet deeply human. Still, even without such speculation, the beauty remains. To know that rivers and neurons and galaxies all whisper the same shape is to see unity in diversity. It is to realize that scale does not erase kinship, that the infinite and the intimate are bound by a single design principle. And in this unity lies comfort. You are not adrift in chaos, but woven into a fabric whose patterns repeat endlessly, from the smallest branching cell to the largest cosmic filament. As you close your eyes, imagine drifting through both worlds at once. Above you, galaxies stream along filaments of dark matter, glowing like lanterns strung on invisible wires. Beneath you, neurons flash with thought, their dendrites stretching out like miniature galaxies. Around you, rivers branch into deltas, roots twist into soil, mycelium spreads unseen beneath a forest floor. Everywhere, the same geometry, the same rhythm of connection and flow. The micro and the macro are not rivals, but reflections. The universe is not only vast beyond comprehension, but intimate in its repetition. To trace its patterns at any scale is to learn something about the whole, and so you are left with this thought: perhaps nature is not a hierarchy of scales, but a hall of mirrors where every level reflects another, where the cosmos and the brain, the river and the filament, the root and the galaxy are all variations of the same eternal theme. And if that is true, then to understand yourself is also, in some small way, to understand the universe. Long before astronomers traced galaxies into maps, long before computers revealed filaments of dark matter, philosophers and poets had already imagined invisible webs. Human beings, gazing into the night sky or into the depths of their own thought, sensed connection. They intuited that the world was not a scatter of separate things, but a woven whole. And so in language, in metaphor, in parable, they spoke of nets, veils and lattices, each shimmering with the idea that all things are bound together. One of the most luminous of these visions is Indra's net, a teaching from ancient India.
Imagine, the sages said, an infinite net stretched across the cosmos.
At each knot in the net sits a jewel, and in each jewel is reflected all the others. To look into one is to see infinity mirrored back. Nothing exists in isolation. Everything contains everything else. The net is a metaphor of interdependence, of a universe where part and whole are inseparable. Though spoken in a time without telescopes, it resonates now with uncanny familiarity. When astronomers describe galaxies strung like pearls along filaments, when they trace the web of matter through space, one hears an echo of Indra's net, infinite, reflective, unified. Across cultures, similar metaphors emerge. The Stoics of ancient Greece spoke of a cosmos woven by logos, a rational order that binds stars and souls alike. In Chinese thought, the Tao is the invisible flow connecting heaven, earth, and humanity. A web without edges, always moving, always alive. Medieval mystics spoke of the chain of being, each link reflecting divine order, from the smallest insect to the farthest star. In every age, thinkers searched for a language to express what science now reveals in data. That the world is not fragments, but fabric. The cosmic web itself, though a physical structure, now carries these older metaphors forward. When we describe galaxies as pearls on threads, when we speak of filaments weaving through space, we are not only describing physics. We are also evoking the language of unity, of interconnection, of meaning woven into matter. Science, in its precision, gives us the architecture. Philosophy, in its wonder, gives us the allegory. Together they enrich our vision, showing the cosmos as both structure and story. Consider the way modern metaphors of connectivity mirror these ancient visions. Today we speak of networks. Internet, neural nets, social webs. We live inside invisible lattices of information, where each point connects to countless others. To log on, to send a message across oceans in an instant, is to experience a human-made echo of Indra's net, each node reflecting the whole, each connection sustaining the system. Our metaphors evolve, but the intuition remains. Reality is net-like, not isolated, bound together by strands both visible and unseen. Some philosophers see in this a principle not only of science or technology, but of existence itself. To be is to be in relation. Nothing stands alone. Every particle is linked, every star connected, every thought arising in dialogue with others. The cosmic web, in this sense, is more than astrophysics. It is an allegory of how being itself unfolds, not as solitary points, but as interwoven threads. The galaxies are not just out there. They mirror the very way in which existence holds together. Others, however, caution against overextending the metaphor. A web suggests order, harmony, symmetry. But the universe is also chaotic.
Violent, unpredictable.
Filaments can break.
Stars explode.
Lives end abruptly. The net is not perfect, nor does it guarantee safety. Perhaps it is better to see it as a reminder of fragility, a vast, interconnected system that is also delicate, where the trembling of one thread may ripple across the whole. Unity, then, is not comfort alone, but also vulnerability. And yet, even with this fragility, the imagery persists. Poets return to nets and veils because they capture something our minds long for, a sense that we belong to a greater pattern, that our small lives are strands in something infinite. When you imagine yourself as one jewel in Indra's net, reflecting all others, you glimpse a vision of wholeness that dissolves loneliness. You see yourself not as an isolated mind, but as a mirror of the cosmos. This allegorical power grows when we place science and philosophy side by side. The cosmic web tells us, with observation and mathematics, how matter has arranged itself across billions of light years. Indra's net tells us, with story and symbol, how meaning may be found in such vastness. Between them, a bridge is built, one of truth, the other of wisdom. Together they suggest that to live well is to live aware of the threads that bind us, to galaxies, to forests, to each other. Perhaps this is why the metaphor of nets returns again and again. It reflects a human yearning not only to know but to belong. To say everything is connected is not simply to describe physics. It is to soothe a deeper hunger, the desire to feel woven into a pattern larger than ourselves. The cosmic web offers a literal image of this truth, a structure written in galaxies and voids. But the philosophical nets, Indra's, Stoic, Taoist, mystical, offer the meaning behind the image. They remind us that connection is not only a fact, but a way of seeing, a way of living. So as you float in imagination through the filaments of the universe, pause for a moment. Picture each galaxy as a jewel reflecting all others. Picture each thought you have as one thread in a vast fabric of minds and histories. Picture each choice you make as a tremor, rippling across the invisible strands that bind us all. And then ask yourself, if the universe is a net, what kind of reflection will you leave shimmering in its infinite weave? When we speak of the cosmic web, it can seem impossibly far away, threads of galaxies spanning billions of light years, structures so vast the human mind struggles to imagine them. Yet we are not outside this web, gazing at it from a distance. We are inside it, suspended upon one filament, in a quiet corner of a spiral arm, circling a modest star. Our planet, our lives, our thoughts, all of it rests within the lattice. The cosmic web is not merely a map of out there, it is the architecture we inhabit. And so the question arises, what does it mean to belong to something so immense? Science gives one kind of answer. It tells us that the atoms in our bodies trace their ancestry to stars, that our solar system was seeded by supernovae, that our galaxy itself is only a pearl on a filament stretched across unfathomable distances. We are not separate from the web. We are its children, its late-born whispers. The same forces that drew galaxies into clusters also gathered the dust that became our world. In that sense, our belonging is literal, physical, undeniable, but philosophy presses further. Belonging is not only about where we come from, but how we see ourselves. To live within a structure so vast is to confront paradox.
On one hand, we feel small, dust upon dust, a brief flicker in the endless play of stars.
On the other, we feel elevated, for even the smallest thread in the web is essential to the whole. Our lives may be fragile, but they are woven into a pattern that reaches across eternity. This duality, insignificance and belonging, is the heart of our relationship to the cosmic web. Stand beneath a night sky and the feeling washes over you. The galaxies are countless, and you are one. Yet you are also the one who can look, who can think, who can ask. Out of all the galaxies, you find yourself here, aware, conscious of the web itself. To be both vanishingly small and yet capable of wonder. This is the strange gift of our place. Perhaps awe is the only proper response. Awe is the bridge between science and philosophy, the state of mind that allows facts to become meaning. When astronomers map filaments, they show us data points. When philosophers speak of nets and veils, they show us metaphors.
Awe gathers them together.
It transforms knowledge into an experience that humbles and enlarges us at once. It reminds us that belonging is not only about location, but about perception. We belong to the web because we can feel ourselves suspended within it. Some traditions teach that to recognize one's place in the cosmos is to find peace. The Stoics spoke of aligning with the order of the universe, living in harmony with what is vast and inevitable. Buddhist thought encourages dissolving the illusion of separateness, realizing that to exist is to interbe with all else. Modern cosmology, in its own way, echoes these ideas. It shows us a universe where nothing is isolated, where galaxies, stars, and lives arise within an unbroken structure. Whether one approaches it through telescope or meditation, the conclusion is similar. We are threads in a fabric, not solitary points. And yet belonging does not erase fragility. The web is vast, but our hold within it is delicate. Civilizations rise and fall on a thin layer of atmosphere, on a fragile balance of climate, on the quiet generosity of a single star. To see ourselves as part of the web is not to be comforted blindly, but to recognize our dependence. We are woven in, yes, but the threads that support us are easily disturbed. Awe, then, is not only wonder but a responsibility. To belong is to care for the strand on which we dwell. Imagine, for a moment, zooming out from Earth. Past the moon, past the solar system, past the spiral arms of our galaxy. Imagine watching as the Milky Way itself resolves into one pearl on a filament stretching across blackness. Now imagine zooming back in until that single star, our sun, comes back into focus, and then this planet turning in silence, and then you, listening, thinking, breathing. The distance between scales is immense yet unbroken. You are not outside that picture, you are within it. You are both the observer and the observed, and perhaps this is the deepest insight. The web is not merely something we look at. It is something that looks back through us. Consciousness is not outside the cosmos. It is one of the cosmos's ways of seeing itself. The galaxies do not know they are strung like pearls. The filaments do not whisper their patterns. But through us, fragile, fleeting beings on a small thread, the web becomes aware. To belong, then, is not only to be placed, but to be a participant in the universe's unfolding story. So what does it mean that we are suspended on one thread of the unfathomable web? It means we are both small and great. Small because our thread is one among billions. Great because we are the thread that asks the question. Our insignificance is real, but so is our capacity for awe, for reflection, for care. To live is to be woven between these truths. And as you carry this thought forward, imagine the web not as something cold and remote, but as something alive with meaning. Each filament is a path of belonging. Each void is a silence in which significance can be felt. Each reflection of galaxies is also a reflection of yourself, woven into the whole. You are here, a thread in the infinite weave. And in that realization, science and philosophy merge into a single meditation. That existence itself is the web, and we, fragile yet luminous, are part of its eternal design. The journey we have taken together has been long and quiet, moving across the hidden scaffolding of the universe. We began in darkness, listening for a tapestry unseen, and now, at the end, the tapestry itself begins to dissolve into us. The lines between observer and observed blur. What was once out there, stretched across impossible distances, now returns to the place where all wonder begins, within. Close your eyes and imagine drifting upward as though gravity has released you. The earth shrinks, the sun shrinks, the Milky Way itself becomes no more than a pearl strung upon a filament. You rise beyond scale, beyond perspective, until there is no more you as a separate figure, but only the pattern you inhabit. You are no longer a traveler through the cosmic web. You are the thread itself. This is not metaphor alone. Every atom in your body, carbon, oxygen, iron, was shaped by processes the web orchestrated. Stars burning, collapsing, scattering their elements into the next generation of stars. When you breathe, when you move, when you think, you are carrying forward the alchemy of billions of years. The web is written into your bones, coded into your cells, echoed in the branching of your neuron. The map of stars is not just above you, it is folded inside you. Science gives us the outlines of this truth, but poetry provides the language to feel it. To say that dark matter binds galaxies is one thing. To say that you are held even now by invisible threads, that every motion, every heartbeat is supported by a lattice you cannot see, is another. Facts are the skeleton, awe is the living breath that animates them. And at this final turn in our journey, awe invites us to let go of the distinction between fact and feeling, between cosmos and self. You dissolve into the lattice. The filaments are not distant highways of galaxies, but the capillaries of your own awareness. The voids are not empty regions beyond comprehension, but the silences in your own mind, where thoughts rest between arrivals. The web is not separate from you. It is a mirror showing you the truth that structure and emptiness, form and void, existence and silence are always entwined. Think of how sound fades into music only when silence frames it. In the same way, the filaments of the cosmic web find meaning only because the voids surround them. Galaxies alone would be chaos. Galaxies within the architecture of emptiness become pattern, rhythm, song. And so with us, we are not only the activity of life, the bustling of thought and breath, but also the intervals, the spaces, the pauses that let us rest. To dissolve into the map of stars is to recognize that both presence and absence are essential to being. Ancient philosophers intuited something similar. Indra's net imagined jewels reflecting each other endlessly, no jewel existing alone. Modern cosmology, with its filaments and nodes, speaks in different language, but echoes the same vision. Everything is linked, each part mirrored in the whole. To dissolve into the web is to realize there is no boundary between your thread and the infinite weave. The reflections pass through you and beyond you endlessly. And here lies the paradox of closing. In dissolution, there is no end. The journey is circular. To dissolve is not to disappear, but to merge, to return, to belong so deeply that there is no separation left to name. The map of stars was never merely a chart of distant galaxies. It was a meditation on relationship, on how every point of light is part of a larger pattern. And now, at the edge of this meditation, you find yourself not outside the pattern, but indistinguishable from it. Notice how comforting this thought can be. The fear of smallness, the anxiety of insignificance begins to soften when you see that to be small is also to be indispensable. No filament, no pearl, no silence within the lattice is wasted. Everything contributes to the shape of the whole. To dissolve into the map of stars is to find peace in belonging, even if the belonging is beyond words. Imagine, once more, drifting into the web. You become the filament, stretching across darkness, holding galaxies as though they were dewdrops. You become the galaxy, whirling in luminous arms. You become the star, burning quietly in nuclear fire. You become the planet, carrying seas and skies. And finally, you become the silence between all things, the vast and patient void without which no structure could exist. Thread, pearl, silence, song, all of it, all at once, and as you dissolve, you feel no loss. There is no fear in this surrender, only expansion. You do not vanish into nothingness. You widen into everything. The map of stars is no longer a picture you study. It is your body, your mind, your breath. Every inhalation echoes the expansion of space. Every exhalation mirrors the cooling of ancient light. You are a rhythm within the universe's symphony. And so our journey through the cosmic web comes to rest here in stillness. If you've drifted with me this far, thank you, truly, for sharing your time and your wonder. Every listener adds a new thread to this unfolding tapestry, and knowing you are here makes the vastness feel a little less empty. I would love to know where you're listening from tonight. A quiet room, a sleepless city, a countryside under stars. Each place is another point of light on our shared map. Feel free to share it in the comments below. If this journey has brought you a moment of peace or awe, I invite you to gently support the channel by liking, subscribing, or simply returning when curiosity calls you back. It helps us keep weaving these late-night explorations together. Until next time, may your nights be calm, your thoughts unhurried, and your curiosity unending. For in the end, curiosity itself is a form of peace. Good night, and thank you for being part of this web of wonder.